Welcome. Up till now we have seen what is meant by root locus, what is meant by angle condition, magnitude condition, what is meant by breakaway point, what is meant by angle of arrival, angle of departure. Now today we will see what are the different steps involved in the construction of root locus. Therefore next point is construction of root locus. Following rules are used while constructing a root locus. Now, rule number 1, the root locus is always symmetrical about the real axis. Real axis means x-axis. The roots of the characteristic equation are either real or complex, conjugates or combination of both. Next rule, that is rule number 2, analyze basic information about the system, which will include first number of open loop zeros, open loop poles, that is P. Second, number of open loop zeros, that is Z. Next, third, number of branches emerging or starting from open loop poles. Fourth, number of branches terminating or ending at open loop zeros. Now, in that first is number of open loop poles, P. Now let CS upon RS is equal to K divided by S into bracket S plus 1 into S plus 2. Always remember, poles are there in the denominator, that is number of S values. Now here 3 S values are there, therefore 3 poles are there. Therefore number of open loop poles, B, number of open loop poles is determined by observing the denominator and number of S terms present in the denominator. Here the denominator consists of 3 S values, that is S is equal to 0, S is equal to minus 1 and S is equal to minus 2. Therefore here number of open loop poles P is equal to 3, as there are 3 S terms in the denominator. Now next, number of open loop zeros, that is Z. For calculating number of open loop zeros, observe the numerator of characteristic equation and count number of S terms present there. For example, let G of S into H of S is equal to K divided by S into bracket S plus 1 into S plus 2. Therefore, in the numerator, no S term is available. In the numerator, no S term is available. Therefore, we can say that here number of zeros Z is equal to 0. Now see this another equation. CS upon RS is equal to K into bracket S plus 1 into S plus 2 divided by S plus 3. Now here, if you will first observe the denominator contains only one S term, that is S plus 3. Therefore S is equal to minus 3. Therefore only one pole is there. Therefore P is equal to 1. And in the numerator, 2 S terms are there, S plus 1 and S plus 2. Therefore S is equal to minus 1 and S is equal to minus 2. Therefore 2 S values are there. Therefore number of zeros Z is equal to 2. Now next, number of branches starting from open loop poles. Branches always start from open loop poles only, and branches terminate at open loop zeros or infinity. For calculating number of branches emerging from open loop poles, analyze the denominator of characteristic equation. Equate the denominator of given equation to 0 and calculate the starting point of the branches. Therefore, To calculate the branches, now equation is there, cs upon rs is equal to k divided by s into bracket s plus 1 into s plus 2. Therefore s into bracket s plus 1 into bracket s plus 2 is equal to 0. Therefore s is equal to 0, s is equal to minus 1 and s is equal to minus 2. That is 0, minus 1, minus 2 are the starting points of the open loop poles branches. Now if P is greater than Z, that is number of poles are greater than number of zeros. Therefore number of branches equal to number of open loop poles, that is N is equal to P. If Z is greater than P, that is number of zeros is greater than number of poles, then number of branches equal to number of open loop zeros, that is N is equal to Z. Now next, number of branches terminating at open loop 0. For calculating number of open loop zeros of the given system, equate the numerator of the equation to 0 and evaluate the endpoints of the branches. There are three cases. Case 1, if number of zeros in the given equation is 0, that is Z is equal to 0, then all the branches emerging from an open loop poles terminates at infinity. For example, consider this equation, cs upon rs is equal to k divided by s into bracket s plus 1 into s plus 2. Here p is equal to 3 because number of s terms in the denominator are 3, that is s is equal to 0, s is equal to minus 1 and s is equal to minus 2, and number of terms in the numerator are 0, therefore z is equal to 0. Now p is equal to 3, z is equal to 0, therefore p minus z is equal to 3 minus 0 is equal to 3. Therefore here 3 branches starts with poles 0, minus 1 and minus 2 and end at infinity because no zeros are there. Case 2, if poles p greater than 0 z. For example, consider this equation, k into bracket s plus 1 divided by s into bracket s plus 2 into s plus 3. Now poles are there in the denominator, therefore here poles are 0, minus 2, minus 3 which is equal to 3, and zeros are s is equal to minus 1, therefore 1 0 is there. Therefore p minus z is equal to 3 minus 1 is equal to 2. So one branch will terminate at open loop 0 and 2 remaining branches tends to infinity. Now case 3, if poles p is equal to 0 z. Consider this equation. For example, cs upon rs is equal to k into bracket s plus 1 into s plus 2 divided by s into bracket s plus 3. Here p is equal to 2 because 2 s terms are there in the denominator and z is equal to 2, that is 2 terms are there in the numerator, that is s is equal to minus 1 and s is equal to minus 2. Therefore here p is equal to 2, z is equal to 2, therefore p minus z is equal to 0, that is 2 minus 2 is equal to 0. Therefore number of branches will terminate at infinity, that is no branches will terminate at infinity. Now rule number 3, a point on the real axis lies on the root locus if the sum of number of open loop poles and the open loop zeros on the real axis to the right hand side of this point is odd. Therefore a point on the real axis lies on the root locus if summation of, or the sum of number of open loop poles and number of open loop zeros is having odd number, then and to the right side of that point, then and then we can say that root locus lies in between that points. If that summation is even, then no root locus lies in that region. Now consider the example, GSHS is equal to k into bracket s plus 1 into s plus 4 divided by s into bracket s plus 3 into s plus 5. Here p is equal to 3 because number of s terms in the denominator are 3, that is s is equal to 0, s is equal to 3 minus 3 and s is equal to minus 5, and z is equal to 2, that is number of s terms in the numerator, that is s is equal to minus 1 and s is equal to minus 4. Therefore p plus z addition we have to make because summation is there. P plus z is equal to 3 plus 2 is equal to 5 is equal to odd. Now to understand the above concept or whatever that concept is there, that is where the root locus region lies, we will consider these two graphs and then you will understand. Now consider point P on real axis. This is the point P on real axis. Now cross represents poles and 0 represents 0, or circle represents zeros. Therefore here poles are 0, minus 3, minus 5, and zeros are minus 1 and minus 4. Now consider right half of the real axis to this point P. On the right side there is one pole and one zero. Therefore first of all what you have to do, you have to take this, suppose 0 point or this first pole 0. Now to the right side of this 0, how many poles and zeros are there? That is the addition of poles and 0. Therefore towards right side of 0, no root locus region is there. Now consider this point, that is minus 1. Here z is equal to minus 1. Now to the right side of minus 1, how many poles and zeros are there? Only one pole is there and 0 number of zeros are there. Therefore p plus z is equal to 1. Therefore since p plus z is equal to 1, addition is odd. Therefore you can say that between 0 and minus 1 root locus region exists. Now consider this minus 3. Minus 3 is pole. Consider this minus 3 point. To the right side of minus 3, how many poles and zeros are there? One pole is there, 0, and one 0 is minus 1. Therefore addition of p plus z is equal to 2. Since to the right side of minus 3, p plus z, that is number of poles and zeros, is equal to 2. Therefore you can say that between minus 3 and minus 1 no root locus region is there. That is root locus doesn't exist. Now take next point, that is minus 4. Now to the right side of minus 4, how many poles and zeros are there? 3 poles and zeros are there. That is 2 poles. P is equal to 0 and minus 3 and z is equal to minus 1, that is 1 0. Therefore p plus z is equal to 3. Therefore we can say that towards right side of minus 4, addition of number of poles and zeros is equal to minus 3. Therefore you can say that root locus region exists between minus 4 and minus 3. Similarly minus 5, to the right side of minus 5, how many poles and zeros are there? Or what is the value of poles, number of poles plus number of zeros? Number of poles are 2 and number of zeros are 2. Therefore addition is equal to 4, that is even number. Therefore you can say that between minus 5 and minus 4 no root locus region is there. Therefore you have to simply understand that if you consider that point, towards right side of that point you have to check how many poles and zeros are there, that is addition of poles and zeros. If addition is odd number, then there exists root locus region between that 2 points. If addition is even number, then there does not exist root locus, that is that region is called as no root locus region. Therefore these are the rules to find out root locus region and no root locus region. Same, we have seen this. Now root locus region, same is there. Again I will repeat. If the RHS of point consists of odd number of sum of poles and zeros, it is root locus region. no root locus region, that is NRL. If the RHS of point consists of even number of sum of poles and zeros, it is known as no root locus region. Now next point, that is next step, is to find out breakaway point. If the characteristic equation has multiple roots, the presence of breakaway point can be concluded as: first, that is A, if two adjacent poles are connected together and region between them is root locus, in such cases a breakaway point exists. That is, these 2 points are there, these 2 poles are there. If they are connected with each other and region is no root locus and region is root locus region, therefore we can say that there exists breakaway point. Next, second, if two adjacent open loop zeros are connected together and region between them is root locus region, in such case one breakaway point exists between them. Therefore these 2 zeros are there. If they are connected with each other and root locus region exists, therefore there exists breakaway point. Next case, if a open loop zero and to the left of open loop zero there is no poles or zeros until negative infinity and region is root locus region, in such case one breakaway point lies in between them. Therefore this is 0 and towards right side, towards left side of it no poles and zeros are there, therefore it goes to minus infinity, and if this region is root locus region, there exists breakaway point. Now rule number 4, angle of asymptote. We have to calculate angle of asymptote, that is theta. This is the equation how to calculate. First of all is theory. The branches which are approaching to infinity do so along the straight lines called asymptote of the root locus. Asymptotes provides guidelines for the branches which approach to infinity. The angles of such asymptotes can be given as theta is equal to 2q plus 1 into 180 degree divided by p minus z, where q is equal to 0, 1, 2 dot dash 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 up to p minus z minus 1. Therefore we have to substitute how number of branches. If 2 branches are there, then we have to substitute q is equal to 0 and q is equal to 1. If 3 branches are there, we have to substitute q is equal to 0, q is equal to 1 and q is equal to 2, and we can find out theta 1, theta 2, theta 3, p minus z. It is simple calculation is there. Therefore angle of asymptote means what? We have to draw the angles, and whatever branches of the root locus we have to draw parallel to the angle of asymptote. Therefore that this is the significance of angle of asymptote, that is root locus branches are generally parallel to the angle of asymptote. Now consider, for example, this example, Cs upon Rs is equal to k divided by s into bracket s plus 1 into bracket s plus 2. Therefore here number of poles p is equal to 3, that is s is equal to 0, s is equal to minus 1 and s is equal to minus 2. Number of zeros are 0, that is z is equal to 0. Therefore p minus z is equal to 3 minus 0 is equal to 3. Therefore we have to substitute 3 values of the q, that is q is equal to 0, q is equal to 1 and q is equal to 2. Therefore theta 1 is equal to 2 into 0 plus 1 into 180 degree divided by 3 minus 0 is equal to 60 degree. Now for q is equal to 1, theta 2 is equal to 2 into 1 plus 1 into 180 degree divided by 3 minus 0 is equal to 180 degree. Q is equal to 1. Now at q is equal to 2, theta 3 is equal to 2 into 2 plus 1 into 180 degree divided by 3 minus 0 is equal to 300 degree at q is equal to 2. Now these are the angles, 60 degree, 180 degree and 300 degree. Now how to draw these angles? We have to draw these angles through the centroid. How to calculate centroid? Next point is there. Here q always starts with 0. Asymptotes are always symmetrically located about real axis. That is, asymptotes we have to plot through a point, that is through the centroid, and that centroid is located on real axis, that is on x axis. Now centroid. Asymptotes provides guidelines to the branches which are approaching to the infinity, but it cannot provide the location of asymptotes in S-plane. All asymptotes intersect the real axis at a common point known as centroid, denoted by sigma. Therefore, the formula of the centroid is given by sigma is equal to summation of real parts of poles of GHHS minus summation of real parts of zeros of GHHS divided by P minus Z. Now again consider this equation. Cs upon Rs is equal to K divided by S into bracket S plus 1 into S plus 2. Here P is equal to 3 and Z is equal to 0. Therefore, sigma is equal to what is summation of real parts of poles. These are the all real values 0, minus 1, minus 2. Therefore, make summation of 0, minus 1, minus 2 minus summation of real parts of zeros. Now number of zeros are 0. Therefore, summation of 0 divided by P minus Z. P is equal to 3 and Z is equal to 0. Therefore, 3 minus 0. Therefore, which is equal to minus 3 divided by 3, which is equal to minus 1. Therefore, value of centroid sigma, we are getting it as minus 1. Now, how to draw? See this. On, we have to draw x-axis. We indicate 0, minus 1, minus 2. Y-axis, imaginary axis. Locate here some centroid sigma is equal to minus 1 and draw the angles. First 60 degree line. This is 180 degree line horizontal and this 300 degree line. Therefore, 3 angle of asymptotes are there which are drawn from the centroid sigma is equal to minus 1. Now rule number 5, locating breakaway point. The location of breakaway point with the help of characteristic equation, that is GHHS is equal to K divided by S into bracket S plus 1 into S plus 2. The characteristic equation is 1 plus GHHS is equal to 0. Therefore, 1 plus K substitute value of GHHS. Therefore, 1 plus K divided by S into bracket S plus 1 into S plus 2 is equal to 0. Therefore, S into bracket S plus 1, S into S plus 2 plus K is equal to 0. Therefore, S square plus S into S plus 2 plus K is equal to 0. Therefore, we are getting by through multiplication S cube plus 2S square plus S square plus 2S plus K is equal to 0. Therefore, S cube plus 3S square plus 2S plus K is equal to 0. Therefore, K is equal to minus S cube minus 3S square minus 2S. Equation 1. Now, taking derivative of K with respect to S, that is dk by ds is equal to 0. We are getting the equation minus 3s square minus 6s minus 2 is equal to 0. Therefore, solving this quadratic equation, we are getting values of s as s is equal to minus 0.42 and s is equal to minus 1.57. Therefore, we get 2 breakaway points. Now, always remember these breakaway points should lie in the root locus region only. If the breakaway point lies in the no root locus region, therefore, since there does not exist root locus, therefore that point is invalid point. Breakaway point should lie in the root locus region only. Now put the value of whatever is in equation 1 and find out the value of k. If the value of k is positive, that breakaway point is valid for the root locus. The breakaway points for which values of k are negative are invalid for direct root locus but are valid for inverse root locus. Now rule number 6, intersection of root locus with imaginary axis. After calculating exact location of breakaway points, we have to find intersection of root locus with the imaginary axis, which will finalize the direction of the curve, which can be done as follows. First, consider characteristic equation 1 plus GHHS is equal to 0, which was obtained during calculation of breakaway points as in rule 5. Second, arrange the equation in the form of Routh's array method to get marginal values of k. Third, after calculating marginal value of k, use the auxiliary equation derivative of a or a of s is equal to 0, that is dA by ds is equal to 0. Fourth, roots of auxiliary equation, that is a of s is equal to 0 for k is equal to k marginal, are nothing but the intersection points of the root locus with imaginary axis. Therefore, consider again characteristic equation g of s into h of s is equal to k divided by s into bracket s plus 1 into s plus 2. The characteristic equation is 1 plus GHHS is equal to 0. Therefore, substitute value of GHHS. We are getting s square plus 3s square plus 2s plus k is equal to 0. Now, we can write this equation in the Root's array as follows. First of all, write s cube, s square, s raised to 0, then this vertical line. Now, s cube coefficient is 1. From s cube, you have to go to s, like this. What is coefficient of s? 2. Now s square. What is coefficient of s square? 3. Then you have to go to like this, k, 3k. Now how to obtain this? Multiply 3 into 2, that is 6, minus multiply k into 1, k, divided by 3. Therefore 6 minus k divided by 3, and again at s raised to 0, k is there. Here below 3 you have to write 6 minus k divided by 3, and below k this 0 will be there. And s raised to 0, same you have to apply. For stability, 6 minus k divided by 3 is greater than equal to 0. Therefore 6 minus k is equal to 0. Therefore k is equal to 6, that is k marginal is equal to 6. For k is equal to 6, take auxiliary equation, that is k marginal is equal to 6. That makes row corresponding to s raised to 1 as row of zeros there, that is 3s square plus 6s raised to 0 is equal to 0. Therefore 3s square plus 6 is equal to 0. Therefore 3s square is equal to minus 6, s square is equal to minus 2, and s is equal to plus minus 1.1414j. Therefore this is the value of s. Now rule number 7, angle of departure and angle of arrival. First, angle of departure at complex conjugate poles. For open loop poles, angle of departure is calculated if the pole or roots of characteristic equation are complex. For complex root is equal to open loop pole, that is phi d is equal to 180 degree minus phi, where phi is equal to summation of phi p minus summation of phi z, where phi d is equal to angle of departure and phi p is equal to summation of phi p is equal to summation of angle of poles, summation of phi z is equal to summation of angle of zeros. Now angle of arrival, for an open loop zero, angle of arrival is calculated if roots of characteristic equation is complex. For complex root which is equal to open loop 0, therefore angle of arrival phi a is equal to 180 degree plus phi, where phi is equal to summation of phi p minus summation of phi j. Now rule number 8, we have to draw the root locus, plot root locus. By using all above rules, plot root locus on the graph paper with proper scale. Rule number 9, comment about stability. From the root locus, draw in above step. Using above steps, comment on the stability of the system by calculating k marginal. Therefore, these are the different steps of drawing the root locus. Now, just by listening theory, you will not understand. We will solve the problems step by step by using these methods or these rules, these 9 rules. Then you will understand how to draw the root locus. Root locus means graphs, remember. It is very simple, it is not that much difficult. Thank you very much.